Hello everyone, and welcome to my presentation on Pointcloud 2. My name is Fatemeh Alidoost. I'm the head of Photogrammetry and Pointcloud at vigram. I'm here today to present you viZone modules, viPoint and viPlan, which are of particular interest to those of you who are using Pointcloud data for your BIM or CAD application. viPoint is an automatic service for optimization, classification, segmentation, and 3D modeling of Pointcloud data. The data could be captured by viDoc devices, UAV or drone-based system, or other tools and sensors. We develop different algorithms so that we can extract high-level information from Pointcloud data, which could be challenging without having a specific hardware or software. Here you can see an example of viDoc Pointcloud, and I want to show you how you can optimize it using viZone modules. At the first step, you can crop the Pointcloud into the area of interest, as shown here in blue color, and you can have the Pointcloud as a segment. As you see, the Pointcloud includes some noisy points, which are coming from a sky or water bodies close to the object. We develop an algorithm that you can also remove those noises effectively. But still there might be some noises which can cause problem for digital terrain modeling. Using ground classification, you can separate those points automatically to ground and non-ground points, or even you can export them only as a ground point. If you are willing to decrease the size of your data and therefore decrease the point density, you can use the thinning tool. This Pointcloud now is good enough for digital terrain modeling. Using the DTM tool under the modeling category, you can define the resolution of the output, and the output would be a thin mesh ready to use in CAD or BIM system. At the last step, we can measure the volume of this stack file. Using the volume calculation tool, you can input the area that you want to measure, and the output would be a CSV file based on BIM standards, including cut and fill volumes. If there are machinery or some construction devices on the stack file, the algorithm can automatically remove them from volume calculation. The viZone is based on batch processing, and it's optimized not only for a small Pointcloud, but also for a large Pointcloud, something like this example. This Pointcloud is about 5 gigabytes and includes different objects. Using the ground classification tool, you can automatically separate your point into two classes of ground and non-ground points, same as here in blue and white color, or you can only export the ground points. On the other hand, the road area are the most important object for road corridor mapping, and 3D precise measurement depends on the quality of the Pointcloud. However, if we look at the area of the road, we can see different noises coming from different objects, cars, traffic lights, traffic poles. Using the polynomial-based road filtering, we can effectively remove all these noises, or we can also have other options using the plane-based fitting algorithm. And you can keep this island untouched and just remove the noises above of them, or you can even keep them untouched without filtering, or you can filter the whole Pointcloud, not only the road areas, but also the other areas. Here you can see we can keep the islands and only remove the noises, or we can keep them untouched without filtering and only filter a road area, or filter the whole Pointcloud. This Pointcloud is ready and perfect for digital terrain modeling. Using the DTM tool in viZone, you can define the resolution of the output in a range of 30 centimeter to 5 meter, crop the DTM, and even if you have a break line, you can insert them to the DTM to have a precise shape of the terrain. This is an overview of the digital terrain model of the whole Pointcloud, that you can have it in one run without resizing or cropping your data. But how we can generate 3D break lines? We can digitize them from ortho image or apply deep learning and artificial intelligence technique to extract those objects. We develop an algorithm based on cross-section that we can extract the upper edges, yellow lines, and lower edges, the green lines, and convert them into the 3D. The algorithm guarantees to find the optimum and correct height value for each 2D vertex. We develop different conversion tools for different objects. For example, main roads in the red line, different classes of points, for example, traffic lights, traffic poles, delineators, and other objects that we have in a traffic area, even, for example, guardrails. Here you can see an overview of the 3D vectorized data and also on the Pointcloud. This data is an input for vPlan tools. Using the vPlan tools, we can generate the output BIM model, and this is As-Built BIM model generated by vPlan tool, and the level of the detail is 400, and showing the current status of the construction site. The whole workflow starting from point cloud optimization, 3D data vectorization, DTM generation, as well as BIM model creation, all can be done in viZone modules using viPoint and vPlan, and for different construction sites and different objects. Here I presented the average processing time for each tool. As you can see, for different sizes of the point cloud, for example, for data smaller than 5 gigabytes, the maximum processing time is 3 hours. Except the plane-based road campaign, which has the maximum processing time. For data larger than 5 gigabytes, the maximum processing time is 6 hours. Of course, it depends on the complexity of the project, the size of the data, and also your requirements. viPoint as a service can provide you with the hardware and software that you need for point cloud processing. Therefore, you can save your own resources. This service is based on batch processing and can handle the different sizes of the data with different objects. As you saw in my presentation, we optimize all algorithms with the minimum option and setting and make them automatic so that it could be easier and simpler for all users and customers. You just need to define your project in viZone, start viPoint, and then come back later for the result. Therefore, you can save time and effort. We constantly monitor and improve our algorithm and support you with your project for point cloud processing. All algorithm and related parameters are documented in R&Ds for your information. However, if you are looking for a specific algorithm for your point cloud processing, you can discuss it with us and we can bring it here live in viZone. Thank you very much, and if you have any questions, my colleagues are here for your assistance.